Okay, chapter 2, day 4. What we're looking at here is what is the test for independence. So we have a way to check to see if two variables are independent or if they're associated with each other, if they're not independent. And so it's a mathematical test that we do, and let's go through how to do it. So the test for independence checks the following relationship. You look at the percentage or the proportion of one of the variables. And you want to know, so this is the equal sign with a question mark, are these equal? The percentage or proportion of that same variable, but given or among the other variable. So this is like a conditional piece, and this is a marginal piece. And if they are equal, then, or not equal, it will tell us a little bit about independence, and we'll talk about that in a second. So, this side is the percentage of A out of the total sample size. So it's whatever A is, it's the total of A out of the total sample size. This side is the percentage of A, but out of the total of B, just among all of B. And what do we know? If they are equal, then they are independent. Think about independent, they're not associated to each other. If they are not equal, then they are not independent. So, not independent would be together, that there is an association. So, and it's just a mathematical test. You just plug in your fractions, convert them to decimals, and you're good to go. So let's take a look at a question that we have. And this is some data that I took around the type of pets people have and the grade level that they are. So here's my grade levels. Here's my pet types: dog, cat, fish, other, and none. And I want to know, is pet type and grade level independent? So I come back to my formula, which is P of A equals P of A given B. Now, I did not specify what pet type and what grade level, so I get to pick any one I want. If this had said, is owning a dog and being in 11th grade independent, then I can't pick. I'm restricted to the dog and the 11th graders, okay? But this one, I can pick any pet type and any grade level. So let's do dog and 12th grade. So let's try dog and 12th grade. So let's try that. So what we're going to do is we're going to look at the probability or the proportion of people in this chart that have a dog. We want to know, is that the same as the proportion of people in this chart that have a dog? Given, or among, or out of the 12th graders. So, the proportion of everyone that have a dog, and out of only the 12th graders, what proportion have a dog? So, proportion of dog owners. I go up, and dog owners. Dog owners, there are 10 dog owners out of 20. Is that equal to dog owners out of 12th graders? So I look at only the 12th graders. And there are 7 dog owners out of 15 12th graders. So I do the math and I get my decimals, and I get 0.5 and this turns out to be 0.46. So now I go back to the statement that I had before that says, if they are equal, then they are independent, and if they are not equal, then they are not independent. So, what do we think? 0.5 and 0.46, are they equal? Are they close enough? It doesn't have to be exact. If you think it's close enough to being equal, you would say these seem to be close enough to being equal. If you don't think they're equal, then they're not equal. I think these are probably too far away, so I'm going to put a line through the equals, meaning not equal. And then I'm going to write a complete sentence, and that's what you have to do as well. Since they are not equal, they are not independent. And I'll abbreviate because I'm running out of room. But not equal, so they're not independent. And that's it. That's the test for independence. It's just a mathematical check of two fractions in which the left-hand fraction is the total out of the total sample size, and the right-hand fraction is the total number of that, what you're looking for, but restricted to one of the other groups. And that's it.